All right, thanks everyone for coming to this session. My name is Ray. I'm a developer advocate for the Google Cloud Platform. I do two things primarily. I love to bring some of our latest and greatest technology, whether it's on Google Cloud or open source, to developers all over the world. I also like to help make our products better and easier to use, especially for Java developers. I've been a Java developer myself for more than almost 15 years now. And it's one of my favorite languages. It's the only language I know. So very happy to be here. My first time here in Ukraine as well, so thanks for having me. Today we're going to talk a little bit about Spring Cloud GCP, which is a project that I started with engineers about a year ago. But I'm also a contributor to other projects. I have my own project called jdbc, and I'm a contributor to JHipster, if you ever heard about that one. Or if you haven't, give it a try. It's a really nice and awesome code generation tool. Anyways, if you have any questions in this session, you can find me on Twitter at Satanism. Also, one thing that I forgot to add here, which is my site. So if you need to find any of the information, you can also go to satanism.me, which is something that I created so that you can find a lot of the information online as well. So, how many people here heard about Google Cloud? Well, okay, that's more than I expected. That's awesome. How many people here are using it? Yeah. Well, hopefully, after today, you'll give it a try, and you'll see what we have done in order to make all of these things a lot easier to use if you are using a Spring and Spring Boot. Now, on Google Cloud, we have quite a few different services and products. We have everything from running your application in a VM to a platform as a service or in containers with Kubernetes. We also have a lot of big data stuff, so you can query data without even running a server. You can query terabytes and terabytes of data in a matter of seconds without having any indices, and that's BigQuery. And then there's just so much things that we can do, like machine learning and stuff like that. But if it's only really useful, I think, that if it's really easy to use and really easy to consume, especially using your favorite languages and or your favorite framework. How many people here use Spring and Spring Boot? Wow, just about everybody. That's awesome, and so do I. And so one of the goals I had for myself, like more than a year ago, was to see that we have some of the best integrations between Google Cloud and Spring applications. And so that we can meet developers where they are, and that we can cut down on a lot of the boilerplate. So the way that this project was structured is that we're working actually hand in hand with Pivotal, our partner, with their engineers, with our engineers, together to define and create Spring Cloud GCP project. It's really just a series of Spring Boot auto configurations and starters that we can pull in the right dependencies for you, and then automatically configure your project, and also using the idiomatic Spring experiences. Okay, so we actually work very closely with the engineers there. They do all the code reviews for us so that we can provide a very good idiomatic experience. There are many things that we cover. Everything here listed, they have some kind of auto configuration. So for example, if you're using like a centralized configuration server today, you're running and operating your own config server, it's actually possible to use a configuration service that's already hosted on the platform so that you don't have to run and manage and keep up maintaining your own config server. We have something very similar, which is called the Cloud Runtime Config. If you have to deal with messaging systems, if you actually have to ever set one up yourself, you will probably know that it's very difficult to have, well, first of all, a highly available messaging environment, and secondly, a scalable one. If you don't want to configure those things, if you are just, you have some business use cases you really just have to get to really quickly, it's very easy to consume and use some of the services on the cloud, and we'll make it super simple to do. Anyways, I'm going to jump into the demo in a second, but just so you know, Spring Cloud GCP has the 1.0 release a couple months ago, and that works with Spring Boot 2.0, and that is part of or it works with the Spring Cloud eventually. And we're actually currently working on Spring Cloud GCP 1.1. It's in milestone 3 today, and that one works with Spring Boot 2.1. and that is going to be part of the Greenwich release train as well. So if you're using Spring Boot, also if you're using Spring Cloud, then this is the release trains that you may want to use. Now, that being said, sometimes people say, wait a second, I don't want everything that's in Spring Cloud. I'm running just a Spring Boot application. Like, I don't want like Spring Cloud Netflix. I don't want Spring Cloud everything else. But don't worry, like if you are using one of these starters, you're really only pulling in the auto configuration for that. So we're not actually taking in all of the Spring Cloud libraries, really. There's really just individual jars that you pull in as you need them, right? So you still try to keep your application thing and only apply whatever that matters to your app. So let's take a look. So for the rest of it, I'm going to show you what this thing can do and how do you actually create an application that's actually somewhat useful. And being able to use some of the services without you having to manage it, I think that's really the key. If you're running and operating your application in the cloud, you really want to try to take advantage of the platform so that you gain velocity, so that you don't have to spend a lot of time maintaining and keep up and scale out the services that we typically do manually, right? And once you see how this works, I hope that you feel like we can actually create something very, very quickly in a short matter of time, and that's actually going to be able to handle production traffic. At the end of this, I'm going to try to deploy everything into some of the runtime environments, including platform as a service and also Kubernetes, if we can get there. Okay? So you're ready to go? Yeah? All right. So I have no backup. I have no video. I need my internet. So, so here we go. So what I'm going to start off with, of course, with the start.spring.io. What I'm going to do is to just create a new application here. Now, one of the things that you will notice is, in addition to web, JPA, and REST repository and actuator, something that we're probably familiar with, I also added this thing called GCP support. What this will do is to actually add the necessary starter and configure your project so that we have the right dependencies for that. Now, there are also many other things that we can add, like GCP messaging and storage, but support is just a generic one so that you can pull in other individual starters if you need to. I'm also going to be using Spring Boot 2.1, and also, just for fun, I'm going to try to use Kotlin for the whole thing. No, actually, I love Kotlin, and it's also it's going to make my code a lot easier to write if I'm live coding it. All right? So, and also for this project, I'm going to use the war packaging. I know you might be like, ooh, war. Yeah, so anyways, you can do war or jar, it doesn't really matter. But I want to do war just so I can deploy it into some of the different environments that we have. It doesn't really matter which part, but I really just want to use war today. So I'm going to generate this project. Hopefully I have internet. I'm going to create this one demo application. I'm going to open this up. And of course, I'm going to try to get this into my IntelliJ. Let's see if that's there. Yeah, there we go. Freshly off the shelf. And let me open up the pom.xml. And I'm going to zoom in a little bit here. Okay, so hopefully you can see it. It's kind of weird. I'm actually right in front of the screen. So hopefully you can see everything here. So as you can see, we're using Spring Boot 2.1. And here we're using Greenwich M3. So that's the latest milestone. And if I scroll down a little bit here, it includes the thing called the Spring Cloud GCP starter. This is really just an auto configuration that's going to automatically discover what's in your class path, and based on your dependencies, we can automatically understand what it is that you're trying to do, and we can configure your application automatically. However, you do need to add the right dependencies. So for example, if you want to use Cloud SQL, like our MySQL database on the cloud, you can also use the SQL driver directly, of course, like you can use a regular MySQL JDBC. But if you want to configure it automatically, then we have a starter for that, which can automatically configure your app, right? And you can pull in the right dependencies by using other starter artifacts. These other starter artifacts basically just add a few dependencies that we know that we need to auto-discover, and so that you don't run into any issues. So with that being said, because all of our project is now part of the release train, so all we need is to be able to import the Greenwich bomb, in this case, And then what I'm going to do is, suppose I want to connect to a database. I guess this is what I'm going to do. Rather than, say, configuring your jdbc driver individually, right, what we can do is to just add a dependency here. Let's say we want to use MySQL on the cloud so that you don't have to manage it yourself. Then we can do something like Spring Cloud GCP. And of course, we have a starter for that, which is the SQL's MySQL. Now, you might be asking, why do I need a starter for connecting to a database? And I'll tell you why. There are actually multiple ways for you to potentially connect to a managed service on Google Cloud. Now, for the SQL service, of course, we can support both MySQL and PostgreSQL. So we have both different database support. And if you also go to create a new SQL database, what you're going to find is that in order to create a highly available database, it's actually quite simple. All you need to do is to set up some kind of replication, a few clicks here and there. Then all of a sudden you have 2 or 3 instances with master and the read workers as well. And then we'll just give you an endpoint. Now, what we actually have done is to create a new instance right now already. This is the instance that I've been using for a while. And in this instance, we can see that this database, by default, will have a public IP address, right? So you can connect to it via the public IP, but of course, you don't want anybody to connect to it, right? Because then that would be a little bit unsafe. So in that case, you may have to whitelist the source connections, which could be an issue if you're running in an elastic environment. Right. So if you set up a whitelisting of IP addresses that can actually connect to the database, then you have to keep track of which IPs can actually connect. If you're in an elastic environment where your infrastructure grows and comes and goes, then you don't know which IP you're going to get, then maybe you cannot whitelist it. The other connection method is to use the instance connection name. And in this case, rather than using an IP address, we just give it a unique name that uniquely identifies this particular SQL instance. However, in order for this connection to take place, we actually have to go through some kind of certificate exchange. And in order to go through certificate exchange, you actually have to configure your jdbc driver with a special additional thing, which is a little bit harder to do. Okay? And so we make that process a lot easier. Or, of course, for an enterprise customer, they probably want to have a private IP access. So rather than having everything exposed on the public internet, what they wanted to opt in for then is the private IP, and then maybe they will disable the public IP so that they can connect it to it directly from the private IP space. Okay? So let's see how this will work. So what I'm going to do is to, let me go open up the demo application here. I'm going to zoom in a little bit. I'm just going to do something very simple here. I'm going to use Kotlin data class. I'm going to create something called person. And then maybe I do a var and co-ID, right, long, because the ID might not be there. And then I'm going to put in something called name. And then, of course, this is I'm going to start out with a JPA entity. So here we go. Let's make this entity, and let's make this an ID. And then we're going to do the generated value. We're going to use the strategy that is just auto. Where's the auto strategy right here? And that's pretty much it, right? Everybody probably have done this already. And then we're going to create a new interface here called the person repository. And we're going to inherit this with the CRUD, paging and sorting repository. And we're going to have the domain as person, and the ID will be a long type. And that's pretty much it. And I think on the top here, if we get REST, where did it go? Repository REST resource, yeah, there we go. And what this will do is to, not only do you have a bean that can do CRUD operation and paging and sorting operations on the person table, but we're also going to expose this via the REST API as well, with just a fully REST, with the post, with the get, with the put, and everything like that. And maybe, well, why don't we start from there, just to make sure this works. I mean, this is pretty simple and straightforward, but we need to actually configure how we want to connect to it, right? So for that, I'm going to go to my application properties. Because we're using a starter, I don't really need to configure my jdbc driver manually. What I can do is to configure my Spring Cloud GCP properties here, and then all we need to do is to give it the instance connection name. What this will do is to actually automatically configure my jdbc driver URL, creates the data source for me automatically behind the scenes, and then you can just consume it. So for that, I need to actually go back to my SQL environment. I need to find the instance connection name. That is a unique name that uniquely identifies this particular instance, which is that one. Yeah, so there it is. And then I need to give it the name of the database. I think I created one which is called people, and that's pretty much it. Then you can use all of the same Spring Data configurations if you want to. So for example, if you want to configure the data source connection pool, I can continue to use Spring Data Source. Depends on which connection pool that you use. Like I'm using Hikari right now by default. I can set the size for that. I can also configure Hibernate if I want to, because I'm using JPA. I'm going to configure the auto DDL here to update my, my schema. So maybe that's it. Maybe that's what I need to do. How many people think this would just work? Wow, nobody. Wow, thank you. Thanks, Sebastian. You're the only person that has a little faith in me. All right, so let's give it a try. I don't want to fail you right now, you know, like that would be pretty sad. So what I'm going to do is to just do a Spring Boot run. Assuming if I have internet, we'll see what happens here. Live demos, we'll never know what happens until you run it. So here we go. So this Kotlin code is compiling into JVM, bytecode, whatever. And my application actually starts. This is a good sign. And check this out. Somewhere along the way, on the top, where did it go? There it is. So we actually automatically discovered the credentials that's currently on my machine, which I'll talk about in a second. And then we also automatically exchanged the certificate. However, in order for that to happen, I mean, you can write, if you want to, you can write this URL yourself. Right? This is just a very straightforward way of saying that I need to use a special jdbc URL that uses the Google driver in a way that is a Cloud SQL instance and so on and so forth. But what this will do is to actually connect me to the instance and then do a certificate exchange so that we can actually connect to the SQL database on public internet via somewhat a mutual TLS connection. So that is pretty cool. It's also authenticated against it with the username and password that you otherwise configure, but this is all going to be over TLS. So it's going to be over a secure connection. And it also automatically discovers the credentials. Now you may be asking, where did the credentials come from? What you need to do in a typical case is that you need to install the gcloud CLI. So this is the gcloud command line interface. And from gcloud, one of the first things that you do is to do authentication. And you can do gcloud logging, and this will authenticate against the Google Cloud Platform. This will open up a browser window. It's going to do an OAuth 2 authentication. And then it's going to store the token, refresh token on your machine. And then subsequently, when you start up your application, it will automatically discover this credential that's on the machine. That's one of the ways. Another way is by creating what we call a service account. So if you're deploying your application onto a production environment, you don't want to do gcloud auth logging every single time. That's just not a good practice. What you want is to create what we call a service account, which is really just a key file that you can associate with any application. So you can create many service accounts. You can create a service account for each and one of the different applications, and every service account can have different type of IAM permissions so that you can have very fine-grained control over this. Okay? So now you might be wondering, like, does this actually work? Does it actually work? There's only one way to find out. What I'm going to do is to do a curl, localhost, and persons. Oh, okay. Oh, nice. Okay, so we actually connected, so that's good. And I have like 15 records here, so we can see this in our Spring Cloud repository, Spring Data repository. That's pretty easy and straightforward. And of course, we can do a post if you want to. So here we can do a curl post. I'm going to take off the ID, and I'm going to say Sebastian, since he's in the room. Sebastian, did I get it right? Almost. Yeah, whatever. What's that? What? Did I still have the ID? Oh yeah, I still need to get rid of it. Whew. Thanks. Pair programming. That's good. So hopefully that will work. And there you go. Right. So that's very straightforward. Everybody's probably doing it today, right? How many people here are using Spring Data and Spring REST and all of these things? Yeah. So let me show you something else that's really cool. If you are running out of capacity on your SQL database, what do you do? You switch to Mongo. Or no, maybe not, I don't know. You switch to a bigger instance, right? And if you're running out of that instance, what do? You add more like readers and writers and all that. If you scale out of that, what do? You shard, right? So you start sharding, and then you have a very big SQL farm. If you want to manage it, you can if you want to. But what we have on Google Cloud is something else that's really, really cool, and it's called Cloud Spanner. Anyone here heard about Cloud Spanner before? Yeah, one person, a few. So this is so cool. So if you ever want to have a relational database that is strongly consistent, that can also scale horizontally, and across the globe, across multiple data centers, then this is something that you use, right? It's called Cloud Spanner. It's based on some of the internal thing, which is also called Spanner. We use Spanner internally for our production workload as well. And let me repeat this. This is a relational database that is strongly consistent, that's also horizontally scalable, and globally distributed, okay? Not many of these words usually go together into a single database, but we can do it. The only reason that we can do this is because we actually have atomic clocks in the data center, so that we have, that's also key to the GPS location of the data center, so we can get very fine, very accurate timestamps of your data, of your operations, so then we can sequence the operations so that we can guarantee consistency. That is really, really cool. And unlike some of the other horizontally scalable databases that's eventually consistent, this is actually strongly consistent. Okay? So in order for us to turn this application into something that can use a globally distributed database if you need to. Not everybody needs to, but if you need to, you can, and this is what you do. Given that you have an existing JPA application, or you're dealing with the POJOs and the object models, then what we can do is this. We can actually get rid of the JPA stuff, because we don't have the JPA integration at the moment. But we can continue to use Spring Data REST if I want to. I don't need the SQL driver anymore. What I need to do is to add the Spanner starter in this case. So what I can do is to say Spring Cloud GCP starter data Spanner. And this is one of the coolest thing, I think, in this whole set of the starters that we have. Just by doing this, now you have access to a simple ORM via Spring Data to actually convert your application. You can keep all the same objects, potentially, hopefully, and then consume the database directly on Spanner. So what I'm going to do is to get rid of all of these imports, which is something we cannot use anymore. I will keep Spring Data itself. I will keep a repository. So rather than using the entity annotation, what I'm going to do is to use the table annotation. Okay? So that is basically an annotation that's specific to Spanner, because in Spring Data, what it wants to provide is the idiomatic way to access the data store. So there are different annotations for different data stores, like Mongo and Neo4j and stuff like that. We have something for Spanner. Okay? And then in Spanner, what we do not have is a concept of a foreign key. And so for a parent-to-children relationship, we actually need to use explicit keys and also composite keys. So typically, what people use in a single, say, MySQL database, a lot of people depend on auto-generated key, right? That's sequential. If it's not sequential, right, it's all auto-generated. The problem with the sequential key is that, well, you actually need to know what number you get next, right? And it will be very hard to scale out, especially globally. So on Spanner database, we actually do not have a sequential key, so we don't have an auto-generated key. You actually have to provide the key yourself. So there's no more surrogate key in this context. In addition to that, for a parent-to-children relationship, because there's no surrogate key, what you really need to do is to just have multiple primary keys. And that's what we used to do in the past, which is just a composite key. So you have the parent primary key, and then also the child primary key column. And for that reason, we have to use a new annotation here, which is called primary key, because you can actually have multiple primary keys in a single table. Okay? And because we're not going to be using auto-generated value, we actually have to switch this to a string. For example, it's actually recommended that you don't use anything that is monotonically increasing. anything that is monotonically increasing could actually create hotspots in a globally distributed system or in a horizontally scalable database. So what we do recommend is to use a generated ID that's usually a UUID v4, only v4, because I think everything else, it's essentially becoming a monotonically increasing ID. So use UUID v4. Very luckily for us, in Java, UUID is actually one of the things that we can use. Okay, so for the interface here, I'm just going to change the key to the key type, which will be automatically marshaled. Okay, and that's it. That's all I need to do to convert this simple application to use Spanner. What I'm going to do is also write a very simple application controller here. I'm just going to call this the hello controller, and of course I can also inject the repository here. So I'm going to use the constructor injection. I'm going to inject the person repository. Oh, sorry, not that one. So private val person repository. I'm going to inject this into my controller. And then this will have a little method here or an endpoint called hello. And then what I'm going to do is to say hello back. But also I'm going to create a person here as I'm going to store it, right? So what we can do is var p, which is a person. And I'm going to use the nice syntax here, which I can set the ID for. So I'm going to say ID, which, remember what we need to do? We need to use a UUID. And again, in Java util UUID, that's actually using the v4 version. So that's going to work just fine. And I'm going to say the name is the name. And then I'm going to put the person repository here. And I'm just going to save the person. And that's really it. Okay? If I go back to the properties file, none of these properties will apply anymore. I'm going to get rid of that. And for Spanner, what I need to do is to give it the instance ID and the Spanner database I want to connect to. So I actually do not have a database I can connect to right now. I'm just going to show you very quickly how we can actually leverage a globally distributed database in just a few clicks. So I'm going to just go ahead and create a new Spanner database here. I'm going to call this DevoxxUA. It's going to automatically configure the instance ID. Within a Spanner instance, you can have multiple databases. So I'm just going to do one single database for now. And then I can configure the regional or multi-regional configuration. If it's multi-regional, I can go across the globe. So that is North America, Europe, and Asia. So maybe I can do one of that. And then if you are running out of space, if you're running out of, if you need to scale out your database, all you need to do is just create more node. This is very, very easy to do, right? And we give you some kind of node guidance in terms of how many QPS do you actually get per node, okay? And then what I'm going to do is just go ahead and create this new database. And it's very quick. It's already done. As soon as I click on the button, now I have a globally distributed database that's actually spanning across Europe, North America, and Asia. Okay, that's super cool. You don't actually have to maintain it yourself. I'm going to go ahead and create a new table here. A new database. I'm going to call it people. Maybe, yeah. And I'm going to add a table. And I'm going to just add a person table here with a few things, ID, which is a string. UUID, I think, have 36 ASCII characters. I'm going to say not null. And then done. Yeah, not bad. I'm going to add a name and then add a string here, which is the name, and done. Of course, you don't want to do this through the UI every time you create a new database. In Spanner, you can also use DDL. And you can send the DDL in via the command line or via API. You can provision your database automatically through scripts if you want to. Okay? And then we can select the key. I'm going to use the ID as the key. I'm going to just create this database and create. So let me come back here. Sorry. So the instance ID is called DevoxxUA, and the database name is called people. And that's all I need to configure for my Spring Boot application. I hope. So let's see if this works. Okay. So let me go ahead and clear this, and I'm going to do a clean and Spring Boot run. I'm a little nervous because you never know what's going to happen when the application starts. So let's see. Okay. So far so good. It also automatically discovered my credentials. It's using my credentials to connect to my database that's, again, spanned globally across the world. And if I'm very, very lucky today, I should hopefully first be able to see that my endpoint works. And the first connection is going to be a little slow. That's because we're using gRPC, and it's initializing the connection. And then the first connection is going to be a little slow. It probably take a second to bootstrap it. But then after that, it's going to be just communicating over gRPC, which is going to be very efficient. And very luckily, I think this is actually working. So why don't we go ahead and do a little say hello. Let me see here. I'm going to say hello. Name is equal to Devoxx. OK, so that should have put my data into the repository via my POJO into my Cloud Spanner database. And if I go back and do a curl again, yes, I can see the entry here with the UUID that I generated. Now, some of you might be saying, hold on a second, this cannot possibly be true. Maybe it is running in HSQL. Right? Maybe it's running an in-memory database. So the only way I can prove to you that this is actually there is to go back to the database I just created, and we can see the schema. But if we go into the data, there we go. We can actually see this new piece of entry being inserted. Right? Now, what's actually possible is for me to deploy this into a multi-regional cluster or a multi-zone cluster in, say, on Google Cloud or somewhere else. Then no matter where you are, you can always access the data that's nearest to you, the closest to your zone, right? So that's pretty awesome. So far, so good? Yeah? And so far, so good for me, because it still works. All right, so what do you do next? Well, if this is a microservice application, of course, you don't just have a single call, right? Sometimes you have a service calling another, right? You have maybe a nested call across multiple services. And then what's really, really important is the ability to have some kind of observability into your application. Now, there are two things you need to do. One is a metrics, right? So you need to know the metrics about your application, like how many requests per second am I getting, how many 200s am I having, how many 404s do I have, and so on and so forth, how much heap am I using. For that, what you want to do is to use, like in Spring, you will probably use like macrometer. So that you can tie this into your actuator, then you can expose Prometheus metrics directly from your application. Okay. Now, for the trace, what people typically use in a Spring Boot application will be in Spring Cloud Sleuth, right? So you can use Spring Cloud Sleuth. You can add the starter to your app, and then it will automatically trace the incoming calls and outgoing calls as well. And then it's going to propagate the trace to Zipkin, or you can run Jaeger if you want to, but typically you will probably run Zipkin to store all the trace data. However, now you have to maintain, again, think about the recurring theme here. Now you have to maintain the server, and you also have to keep it up and running. You have to make sure it's highly available. You have to be able to store a lot of traces, and then when you actually have an issue, you have to be able to find the data very, very quickly. If you don't want to maintain your own server, then we have something else that's pretty awesome. It's called stack-driver trace. So you can actually propagate all the traces directly into our stack-driver trace service. Then you don't have to maintain and manage your own service anymore, right? It was very, very easy for developers to take advantages of. So what I'm going to do is to basically write another method here to simulate a service call. So that I cannot just write two services right now. I'm just going to use the same service to simulate one service calling another. For that, I need to initialize a REST template. For example, let me just make sure this auto imports. Yeah. So we have REST template Bing, and then I can put the REST. I can inject it into my application here into my class, and this is the REST template. Yeah. There we go. With the constructor injection. And then what I'm going to do is to just iterate through a few names so that I can call, I'm going to call myself, but over the HTTP call here, so when I'm simulating another microservice call, right? I'm going to iterating through a few names. Ray, Mandy, that's me. Mindy, she's awesome. She's one of my colleagues. And Jisha, also one of my colleagues who actually worked on this project as well. So what this will do is to simulate the call. So I'm going to call all, and I'm going to call a few other, call myself, call another service 3 different times. If I want to trace this, what I need to do is to add a starter for Spring Cloud Sleuth, but then that will get you the exporter so that you can send the traces to Zipkin. To make this a lot easier, we have a really nice, easy-to-use starter here, which is Spring Cloud GCP, Spring Cloud GCP, starter trace. Okay. what this will do is to automatically pull in Spring Cloud Sleuth, but also the necessary exporters so that we can propagate the trace directly to Stackdriver trace. We'll also automatically configure this so that we can discover your credentials automatically. We'll automatically configure the exporters, and this is all you have to do. That's it, okay? So now you have everything that you need from Spring Cloud Sleuth, but also you can propagate the trace directly to our service. The other thing that I really like about Sleuth is that if you do have your trace information, you have your trace IDs and you have your span IDs, what Spring Cloud Sleuth will do is to actually output the logs with the right trace IDs into the log entry, right? We can actually capture that. We can also forward the log directly into our centralized logger if we want to. And to do that, we can just add a starter here, which is called the logging starter, okay? However, you do need to configure this a little bit more. I'm going to show you something very quickly here. I'm going to overwrite the logback configuration. And then I'm going to use my API and console appender. So basically what this will do is to output my log on the console so I can see it right now. And I'm going to also propagate the log entries into a centralized logger. Okay? And the centralized logger is Stackdriver logging. And then we can actually see the log messages in a central place. And then we can query it. We can do analysis on it. We can even capture error messages so we can notify you automatically. Okay, and that's pretty much all we need to do. So why don't we give it a try? Hopefully this will work. So I'm going to stop this again, shut it down, do a clean and do the rerun. Now remember what we just added. We're talking to the spanner database. We added trace so we can do distributed tracing, and then we're also logging into a centralized logger. Okay, don't worry about the exception on the top. That always happens for some reason. Yeah. So we started our application. Oh man, this is too hard. Okay, and then I'm going to just hopefully code the O endpoint. And well, hold on a second. Let me make sure this still works. So I'm going to code persons. Persons. Oh, that should be people, right? There's no such thing as persons. It should be people, right? Anyways, so we have persons. That's good. That still works. And I'm going to call O. Now, when I'm calling O, we can see the log messages being outputted. We can see the trace ID. Oh, check this out. I did miss one thing, which is this little flag here, which is false. When this is, if you read the log, if this is false, that means that this particular span, this particular trace, is actually not being sampled. What that means is that we have the trace ID, but we're actually not going to store it anywhere. And this is by chance, this is by probability. And to make this demo work 100% of the time, I need to change the chance of this, right? So in Spring Cloud Sleuth, you have a little flag here called probability. By default, it's going to only trace 10% of the request, because typically in production, you don't want to trace everything that you have. But for the demo, I'm going to up it into 100% so that we can sample every single request, okay? So when we sample every single request, what that means is that not only do I have the trace ID, but when this flag is true, it will also be propagated and stored into our centralized system, okay? So let me try this out. And we're going to be, yeah, here we started pretty quickly. And I'm going to curl O. Remember, the first request might take a second or two. And then the subsequent one will be much, much faster. And now we can clearly see that the trace is now true, right? Now it's actually being sampled. What that also means is once the trace is propagated into the server side, then I hope I can see it in my list of traces. So these are all the traces that's been happening in other systems that I have in my project, but here's the trace that I just called just now. In this trace from Spring Cloud Sleuth, it's automatically propagated into the system, so you don't have to manage it yourself, and you can see all the requests as well. You can see the first one took a longer time, and then the subsequent one, of course, is much, much faster. And then if you scroll in here a little bit more, you can also see, let me see here, you have two spans here. That is the client-side span. That is the person who's making the call. Sorry, that's the span that's associated with the caller. And then the second one is the server-side span, right? So this one tells you when did you actually get the data back. This one tells you how much time the server actually processed it. And on the server side, of course, I can see all the basic information here, like I'm calling the hello controller. I'm also using the hello method. So we store some of these information in detail. The best part of this, though, is I remember I'm also propagating the logs directly into the centralized logger. What that means is now I can go to my logging console to see it, but because I also associated the trace ID and the span ID, we have this little button here called Show Logs. This is super awesome. So I can click on that, and you can see the log messages associated with each individual call. And this is super useful, especially if you have error logs where this will become error, this will be red. Then you can see where the error actually occurred, and you can see which service, which component it actually occurred in. And that can be super useful when it comes to debugging and troubleshooting scenarios, okay? If you're doing asynchronous microservices, some people like to use like CQRS or even sourcing and stuff like that, or which is basically a message passing, so you want a middleware. Again, how many people here set up a highly available messaging system yourself, like RabbitMQ? No? Yeah, there you go. Sorry, it's just a lot of work. Or HornetQ or something like that, right? I've done it before. I used to work at Red Hat. It's not easy. You have to have a lot of infrastructure to do that. If you want to have something very quickly that you want to pass messages along, this is what we do. We call this a pops up. Okay? So this is a very quick intro to what you can use on the cloud platform. So pops up, again, just like Spanner, which is globally distributed, pops up is a global messaging system. So whenever you create a new topic that you want to subscribe from, you just create one, and it'll be highly available and global. That is, it's a concept that's been hard for me to grasp personally, because as a developer, using a lot of the on-prem stuff for a very long time, to provision a messaging system will probably take a whole year. I don't know, like from the moment that you need it to the moment that you have the machine to the moment you can actually use it, takes a long time. Here we can just say, I need a new topic. It's called people topic. I'm going to go ahead and create it. And that's pretty much it, okay? And then in the people topic, I can create a subscriber if I want to, if I can find it. Let me see here. Do a quick refresh. There is the people topic. I can go into it. If I need to subscribe it from my application so I can process the incoming messages, then I can create a new subscription. There we go. I'm going to call this the people subscription, something like that. So every time I'm saying hello to somebody, I'm going to push it to this topic, and I'm going to subscribe from it as well. You can have multiple subscriptions on a single topic, because it's one to many. You can also have multiple subscribers on a single subscription. Okay? So if you create a subscription like this, I can have multiple workers to subscribe, and they will fight with each other to grab the message off of the topic, off of this particular subscription. You can have other subscriptions as well. They can subscribe to whichever one they want. So in order for this to work in, with the Spring Cloud starters, again, you probably get the drill. We have a starter for this too, and it is called the Spring Cloud GCP Pops Up Starter. If I can find it, there we go. Now, you notice that it didn't really need to specify the version in any of these, because all the versions are being managed by the BOM, so I don't actually have to specify the versions. And the starter actually works with, if you're using Spring Cloud Stream, if you're doing stream processing, this works with Spring Cloud Stream. We provide the right abstraction layers for that. If you're doing ETL jobs with Spring integration, this is also integrated directly with Spring integration too. So either way, what this will give you is a way to access your messaging system through the Spring ecosystem, through the Spring abstractions, and you don't really need to know whether you're using PubSub or RabbitMQ or Kafka behind the scenes, right? All of those things will be abstracted away from you. I will just show you something pretty simple, which is to use it as is with a template. So in addition to the abstractions you can use, you can also use the template. So in order for me to publish a message whenever I get a hello here, I'm just going to automatically inject private val PubSub template. We will automatically configure these templates for you and configure it with the right credentials. I'm going to create a new thing called the publisher template, so I can publish a message. And every time after I save a person, I'm going to use the publisher template. I'm going to go ahead and publish the payload, and I'm going to publish it to people topic. And here I can say received name, okay? And that's it. I can just push this. You can push whatever you want. We can also use the Spring serializers to convert it into the data payload that you need. Okay? And that's all we need to actually push the message. What I'm going to do is to restart this app. And while this is being restarted, I'm going to also show you how I can get the message off of the queue. To do that, we can also write something very quickly. For this, I'm going to create a new Java application. And all I'm going to do is by using GCP messaging. Okay? And I'm going to code this the demo receiver. And this is just a new application I'm going to create that will have the pops-up starter configured automatically for you. I will open this up very quickly. Come on, open, open, open. Where did it go? Uh-oh. Where did my, oh, there it is. Yeah, there we go. And this would have pops up configured for you automatically, right? Right here, there's the pops up starter. I'm just going to write something very quickly that will receive messages from the queue. Of course, you can make it much more complex depending on your use case. But basically, what I'm going to do is to create a new bean called the command line runner. This is a really easy way for me to run something just without a web server. I'm going to return, and this is going to give me the args. There we go. All right, so every time I start this application, the command runner will actually be executed. And what I'm going to do is to automatically use the subscriber template. Here we go. I'm going to call it the subscriber template. And then I'm going to subscribe to the subscription. So I can do subscriber template.subscribe. And the name of the subscription is called subscription. Is that right? Yeah. There we go. And we're going to get a message in. And then with this message, we can go ahead and process it. So all I'm going to do is to do a system out.println, the best way to log something. And I'm going to say message, get pops up message. And I'm going to get the data. And I'm going to convert that into a UTF-8 string. I'm going to print out whatever I sent in. And then it's very, very important that you either ACK it or you NACK it, right? You either acknowledge that you have received the message and you processed it, or you NACK it, then it's going to go back to the queue, and somebody else will pick it up and process it to do a retry. So in this case, I want to make sure that I ACK it so that I don't have the duplicate messages on my topic. And that's all I need to do. So let me go ahead and run this as well. Oh, boy. Hopefully this will work. We're going to find out pretty soon, right? So here we have messaging up and running. Very quick. Bootstrap my credentials, open up the gRPC connections to my pops-up service. Now I'm listening to messages. So if everything works fine, oh, shoot, did I just shut that down? I think I did. Sorry. Let me restart. Run Control-C in the wrong window. OK, so let me restart this again. Now, maybe I should put this into that window, yeah, for now. Yeah, OK. So up and running soon. Yeah, there we go. And then I'm going to say hello all again. So this should hopefully not only save the data to the database, but also publish my messages on the queue. And you can see, oh, sorry, it's right behind me. There we go. Oh, what the? Wrong side. There we go. Now you can see it, right? So let me try this again. I'm going to say hello to 3 people. We're going to push things onto the queue. And then you can see the receiver just receiving it. And you can see it's very, very easy, straightforward. It only took about 3 lines of code to get this done, right? That's super awesome. Now, we have the option now to deploy this application into App Engine, which is a platform as a service, right? Everything will just work as is. Or we have the option to deploy this into Kubernetes. Now, I want to do a poll. How many people want to see this deployed into Kubernetes? Okay, about 5, 6 people. How many people want to see this deploy into App Engine? There are a few people here as well. How many people? A lot of people didn't raise their hand. How many people you don't want to see it deployed anywhere? There you go. Into another cloud, maybe? Not today. Anyways, but you can if you want to. Remember, all of these services are just services. You can actually deploy this into different environments on-prem, as long as you have the right credentials. Okay, so everything will just work. So why don't I do both? I'm going to try both. Depending on the time, let me do both. So what I'm going to do is, first of all, in App Engine, we'll automatically propagate your logs into a centralized logger already. So for that reason, I am actually not going to use the log back here. I'm just going to get rid of the stat driver logging here. I'm just going to print it to console. Okay? In all cases, you do not want to propagate the log to the file system. In all cases, you don't want to write to the file system at all. For me to deploy to App Engine, this is something we can do. In the IDE, we have this thing called the Google Cloud Tools. I can just simply go ahead and add App Engine support. I'm going to add it to this project. I'm going to just make sure everything is configured. And what this will do is to create what we call the App Engine. Oh, sorry. There we go. We create a new App Engine web XML. And here we can configure this application. For example, we can have it run on a bigger machine. By default, it's going to be automatically scaled. Or you can do manual scaling if you want to. So automatic scaling will just automatically scale out your application to as many instances as you want. And if nobody's using it, we'll scale this back in to 0. We have had this for decades. This is probably the original serverless platform, if you think about it, right? So I'm going to do a menu scaling here. I'm going to run one instance for now. And then what I can do is to just edit my configuration. I'm going to say I want to run it on the Google App Engine deployment. I'm going to deploy the WAR file. This is the reason why I wanted the WAR. And I'm going to use my project here. Just configure that. We can also deploy multiple versions of your application as well. If you have like a new version, you can just update the number of the version here, and then you can pick and choose which version you want to route the traffic to. So I'm going to update this to version 3 and apply it. I'm going to go ahead and go, and I'm going to say, run. So hopefully that will just all start. We'll see if that, I think I made a little mistake here, but we'll see if that works. And let me see here. Let me just go to demo. Maybe clean compile in a second. All right, so now this is actually deploying my app into my App Engine environment. We will give you a URL and also the HTTPS endpoint so that this is all secured by SSL, just out of the box. You can also use your own custom domain name if you want to, and that would just be, you can also use Let's Encrypt against the domain name, and everything will be secured as well. Okay? And that should be done pretty soon here. Oh, yeah, so F4 is only, yeah, I did mention I probably made a mistake. So F4 instance type, this is just a bigger instance. It's only allowed if I'm doing auto-scaling. So rather than doing that, I'm going to use B4, which allows me to use auto-scaling. When you run your application in App Engine, you got to be really careful about the amount of memory you're going to consume. Because the default instance size has a smaller memory footprint, then your application may not actually start properly. Okay, so let me just do this again. I'm going to do this deployment. While we wait, I'm also going to convert this into a container. The way I'm going to do it is by using a really, really awesome plugin called Jib. Okay, I don't know if you heard about Jib before. Jib is a project coming from Google. It's basically a Maven or Gradle plugin that can turn your application into a Docker container, applying all of the best practices that you need. So for example, you will layer your file system properly so that you get the best efficiency when it comes to building a small image. And while using Jib, what I need to do is to make sure that it will actually introspect my build file. It will actually go through all of my dependencies. It will automatically discover the dependencies and build my image for me. Okay? And I can build it to Docker Hub, or in this case, I'm going to build it into my GCR.io. I'm going to build it into my private registry on Google Cloud at this moment. I'm going to call it Wise Coyote 827. That's just the name of the project. And I'm going to go to this DevoxxUA demo. Okay? And with that all being done, what I can do is to just do a Jib build. So I don't actually need to write any Docker file in this case. I don't need to write my Docker file. All I need to do is to call maven Jib build, and it will automatically discover my dependencies. It will automatically set up a base image for me. I can, of course, use a different one. You'll also put the dependencies into its own layers. It's going to put classes in its own layers, and so on and so forth. And this is all done without a local Docker daemon. So you don't need to run Docker locally. You push directly to the remote registry, and this is ready to be used. Okay? Then what I can do, if I want to run this in my Kubernetes environment, I can just do a kubectl run, DevoxxUA, image is that, and maybe true replicas. And this will deploy my newly created application into container, into my Kubernetes engine. There we go. and then I'm going to go ahead and expose my deployment, which is DevoxxUA. And I need to set the type to load balancer, so we have a public IP address to access. And I'm going to listen on port 80. I'm going to target the port in the container for my Spring Boot application on port 8080. And this will actually instruct Kubernetes to create a real load balancer on Google Cloud with an external IP address. I'm going to wait for that to start. Okay. So, for example, right now my application is up and running, which is nice. And I will have a service endpoint in a second when I have the external IP. In the meantime, I'm just going to go back to my App Engine application, which I just deployed. I just created it. And I should be able to see persons, which will get me the person's REST repository. And I can see all my application, so all of the data there, which is super awesome. Oh, just by a few clicks, right? And one of the coolest things here is I can actually debug this application live if I want to. So if I go to my Google Cloud Platform, if I want to debug my application, it actually has the debugger attached automatically. And this debugger it does not stop the world. It will actually allow you to do something pretty cool. So what I'm going to do is to just upload my source code into my environment, into the debugger. There we go. I'm going to upload it. If you have the right plugins, if you have the right information, we will automatically check out the source code for you. But if you didn't do that, then you can upload the source code yourself. And then we can do a few interesting things. So for example, if I want to add more logs, this is what I can do. I can just say, here, I need to add a new log, and calling another service, right? So that's number one thing we can do. The other thing that we can do is to add a snapshot, which will tell you the exact code stack that's happening at this very line of code, for example. That being done, I should be able to go back to my app. Why don't I just, let me see here. Which one is that one? Add it to hello, right? I'm going to add a log message here, too. Hello to name, right? Do something like that, right? So now check that out. I'm going to, where's my snapshot? Right here. Oh, sorry, snapshot is right here. I need to click on it. All right, so check this out. I'm going to trigger it. Bless you. Hello, Ray. This should trigger the line of code that I'm waiting for. And very quickly, you can see a snapshot being taken on the code stack of this very application. I can see the variables that's coming in. I also see the stack that's actually being called, so I know which methods are being called in this case. Right, that's just out of the box with the App Engine. That being said, let's go back, because I'm about to stop this talk. Let me go back to the service. I should have my application running in Kubernetes as well. I have a new endpoint here. And if I actually go to this environment, I see the same app. That's also the same application running in Kubernetes. I can, of course, go to persons, and I can see my repository. And of course, I can, of course, go ahead and say hello. Dave is in the room, so I'm going to say hello, Dave. And that's pretty much it, right? So I took a little time to go through everything in detail. But once you understand how this thing works, you can really create really useful applications for your business and for your clients or for your customers, whatever, in a very short amount of time without actually having to go through and maintaining the infrastructure that you are running on, right? So for example, I personally have created this site with a few other people. It's called Pi.delivery. I don't know if you celebrate Pi Day here, but basically what we did is we provisioned a machine to calculate 750 billion digits of pi, okay, in a matter of a few hours. And then we created this infrastructure to serve it. But I was also able to, what I did is I was trying to index 750 billion digits of pi so that you can have a reverse index to look up your own phone number, for example. So you can give your phone number, will tell you which digit that phone number is in relation to digits of pi. I was indexing 750 billion digits, and I was personally writing 500,000 records per second just by a few clicks into Bigtable and to build this reverse index. However, when you put everything back into perspective, to index that many digits, even at 500,000 digits per second, it will take me about 21 days to finish it, right? So it's just incredible scale that you can get just by a few clicks. But then when you're dealing with really, really large data set, you still have to scale this out even more, and you can do that on Google Cloud Platform. Anyways, if you want to learn a lot more about the starters, we have a lot of resources here. First of all, we have the project homepage. You can go to. We have really, really nice reference documentation. Josh Loam from Pivotal, awesome Josh, my good buddy on Pivotal. He also wrote an 8-part series that you can actually read and do directly from his blog as well. And then if you want to do a hands-on with a short, if you have like 30 minutes, go to the short lab. If you have like 3 hours, you can go to the long lab. You can try everything out that I just showed you today. Okay? So with all that being said, thank you so much for your time, and thanks for having me here. I really appreciate it. Thank you.